Hello, today we will be demonstrating the NIS 3070, a new 48-volt high-current eFuse. With the trend of higher and higher densities being seen in the telecom industry due to the proliferation of 5G and massive MIMO, a multi-channel 48-volt high-current protection device is needed to cover all the necessary RF power amplifiers. The NIS 3070 acts as a high-side switch, while also providing overcurrent protection to all downstream components, connectors, and wiring in telecom and industrial applications. This device has 4 channels, allowing protection of 4 independent loads of up to 2.5 amps each, or the channels can be tied together to drive a 10 amp load. The NIS 3070 also features digital enable pins for each channel, fault reporting, and adjustable current limit through a dedicated pin. My colleague will now show a demonstration of 12 of these devices in parallel, driving an 85 amp load, the overcurrent response, and capacitive load charging.
Hello, today we're looking at a demo for the NIS 3070, a new 48-volt high-current eFuse. Basically, we have a circuit where we have a 48-volt DC rail, and then we have 12 NIS 3070 devices in parallel so that we can achieve very high current, and then we have 3 different load situations. The NIS 3070 is capable of 10 amps DC per unit, but it can be paralleled to achieve higher currents. So the first thing we're going to show is what happens when we switch in a load resistor that will allow us to draw 85 amps. So we're going to hit single on the oscilloscope, and then we'll hit normal operation. What we're looking at here is basically that the current went from 0 up to 85 amps for about 20 milliseconds. The combined RDS(on) of all 12 devices is lower than 2 milliohms, so the 85 amps can pass through without much of a voltage drop over the eFuse at all. Next, we'll look at what happens when there's an overcurrent situation. We'll hit the button for faulted operation. And what happened here was the eFuse went from 0 to 85 amps. This is a normal operation, everything's fine. And then all of a sudden an extra 50 amps is drawn. This eFuse has 2 current limits. This current limit is called ILIM. It observes that the current is above a certain threshold, waits for 500 microseconds, and then shuts down. Finally, we're going to look at what happens when we charge an output capacitor. The eFuse has a controlled slew rate feature. We're going to be charging a 470 microfarad capacitor. Here we can see that there wasn't a lot of inrush current going into that capacitor. It was just a very small amount of current that was very well controlled.